This is part 3 for nomenclature of alkanes, and in this video we'll talk about numbering parent chains. So here, let's identify our parent chain first. So here, for this molecule and for this molecule, my parent chain has 5 carbons. So in both of these are both pentanes. Now let's look at how to number these. There's 2 different ways I could number. So let's look at this one here. So I have 1, 2, 3, 4, 5. So I could number my carbons in that direction, sorry. Alternatively, I could number the carbons this way. So 1, 2, 3, 4, 5. And you can see here, this makes a difference, right? If I'm looking at where is my substituent, so I have a methyl group. If I number it in blue, the way I did it in blue, I would have that methyl group on carbon 2. But if I number it the way I did in green, the methyl group is on carbon 4. And the proper way to number this is in blue here. And the reason why is that when we are numbering and we have 2 different ways we could number it, and there's only one substituent, we want to give the substituent the lowest number possible. So in this case, that's 2. So how I would name this molecule is 2-methyl pentane. So again, the pentane is telling you have a 5-carbon main chain or 5-carbon parent chain. And the 2-methyl is telling you that on carbon 2 of the parent chain, there's a methyl group. Okay. And to review again, between a number and a letter, there's a dash, and then there's no spaces in the name. So it's all one word. Let's look at the next one. If I number from left to right, 1, 2, 3, 4, 5. In this case, it's the same as numbering right to left, 1, 2, 3, 4, 5. Because either way I number, my methyl group is on carbon 3. So in this case, it doesn't matter which way you number it, because again, in both circumstances, your substituent, the one only substituent you have, has the same number. So I would name this compound as 3-methyl pentane. So let's look at some rules here. So again, this is the rule I just covered. If there's only one substituent present, you're going to give that substituent the lowest number possible. So here you can see 2 different ways of numbering. Here, numbering left to right puts your substituent on carbon 2. Here, I'm numbering right to left, and that puts the substituent on carbon 6. So this would be the correct way to number the parent chain. If there are multiple substituents, you want to number the parent chain so that the first substituent has the lowest number possible. So here, if I'm numbering left to right, the first time I come along a substituent is at carbon 2. So here in this numbering, I have 2, 5, and 5 for my substituents. If I number right to left, I have substituents at 3 and 6. So I have 3, 3, 6. So the first substituent, again, we want that to have the lowest number. So the 2, 5, 5 numbering will beat the 3, 3, 6. First substituent gets the lowest number. If there's a tie, you will number the parent chain so that the second substituent gets the lowest number. So if you look at this way, the numbers for substituents are 2, 3, and 6. If I number this way, my substituents are 2, 5, and 6. So the first substituent is the same for both, it's 2, but the second substituent, that's different. In this way, it's 3, and this is 6. So 5. So 3 beats 5, so this would be the correct way to number this molecule. If there's no other tiebreaker, so in this case, no matter how I number, substituents are on carbons 4 and 5. You assign the lowest number to the substituent that comes first alphabetically. So in this case, I have an ethyl and a methyl substituent. So ethyl comes first alphabetically. So ethyl will get the lower number. So this would be the name of the molecule. When you have cycloalkanes, the same rules apply, but if there's only one substituent, no number is needed. So for example, if you have this here, only one substituent, so we would call this methyl cyclohexane. I don't need a number here because no matter where I start in the ring, if I'm numbering with the substituent having the lowest number, that will always be carbon 1. So here's an example. Here, if I number this way, I have two substituents on 1 and 1 on 3, so 1, 1, 3. If I number this way, I have substituents on 1 and 2 on 3. So 1, 1, 3 will be 1, 3, 3.